This is lesson 2 of chapter 9, the second half of it. So yesterday we got started on this. Okay. And yesterday we did some practice problems. We started, the first set of things we did was going from moles of some known amount, one of our substances in our equation. We used a mole ratio to find out how many moles of another substance we would need or we would produce. And then the second set of equations, we started with the moles and we went to mass. So we did a mole ratio and then a molar mass conversion. Okay. Today we're going to do the opposite of that one, where we're starting with mass. We're starting with something given to us in grams. So we'll do a molar mass conversion first, find how many moles we start with, and then we'll do a mole ratio and find the number of moles of whatever substance we're looking for. And then we'll do a set of problems where we start with mass and we end with mass. So we'll have to do the whole set here. So again, those are the hardest ones. They're just the most steps, and so there's more places for you to mess up, so pay attention. Okay. The last type, the mass to mass, starting with mass and ending with mass, those are the most useful. They're the ones we do the most often probably in chemistry, because remember, when we're measuring, we're actually trying to figure out, like measuring out the amount that we need. We don't have a scoop that can measure in moles. We don't have a balance or anything that can measure in moles, because that's a number of atoms. So in order to figure out and actually measure out our amount that we need, we have to have the mass. Okay, so the mass to mass conversions tend to be the most useful and the most used. So make sure for today that you have your periodic table. If you don't have it out yet, get it. And you have a calculator that I just threw on the table. It's fine. Okay. So those are the equations that we're going to be doing. Those are the steps. So let me go to my phone here. It's going to take just a second to get this going. So sorry. And then I'll probably have to adjust the view just a little bit. And it takes, there it is. Let me go to my camera. Okay. Ooh. All right, so you have this in front of you, or you should. Just a little bit. So if you can't read absolutely everything, that's okay. You should be able to see it on your table in front of you. Okay, so I may end up sliding out of the frame a little bit here, and that's all right. So our first set, like I said, we're going to start with, in this case, we are given mass, and we're going to find the moles. And so we're doing two problems that are based on, or two calculations based on this problem here. So in case you're wondering, this is how we can make nitric acid. Okay, NO. Oh no, this is the first step of making the nitric acid. Sorry, that's not nitric acid. And this one is not balanced. So our first thing we have to do is, of course, balance the equation. Okay. So you should pause and you should balance this equation. Make sure you remember how to do that. And when you've balanced the equation, you would find the coefficients to be four to 5 to 4 to 6. Okay. I'm going to assume that you paused and did it and didn't just cheat and look at the answers like I did. Okay. So we start off with a mass of ammonia. So we start with 824 grams of ammonia. And for this one, the first thing I want to find is the moles of nitric oxide or nitrogen monoxide. Okay, so I'm first going to start with my 824 grams of NH3. So because I'm given grams, the first thing I need to do is a molar mass conversion. where I go from grams of NH3 to moles of NH3. And then my second step will be to go from moles of NH3 to moles of NO. And that's what I'm looking for, so I can stop at that point. Okay. So in 1 mole, because molar mass is how many grams do you have in 1 mole? If you look on your periodic table, nitrogen is 14. Each hydrogen is 1, so 14 plus 3 is 17 grams. And then I go find my mole ratio. I have 4 moles of NH3 and 4 moles of NO. So that's going to be a nice little thing here to cancel those out for us. So in this case, we don't have to multiply by the 4 or divide by the 4 because that's 1. So we would just, into our calculators, plug in 824 divided by 17. And we should get, push the right buttons, about 48.5. Okay, so remember at each step, I know you don't want to write these all in. I know, you just want to write the numbers, but it really helps to keep track of where you're at in the problem if you write out that you have grams and what substance, or you have moles and what substance you have. Okay, it keeps you on track. Okay, in the second part of this, we're going to figure out how many moles of water are formed. So we're doing the same thing, but we're going to moles of water. So I'm going to do it somewhat quickly. Okay, so I know that the molar mass is 17 grams. And then I have 4 moles of NH3, and then I have to look up here, and I get 6 moles of water. Okay, and then by writing this all out, you're also letting me know if you make a mistake. So if you had accidentally written 5, right, or 4 again or something, I would know, okay, well, obviously your error was in which mole ratio you used, okay? Or if you write the wrong substance, that tells me where you messed up, and I can help you and fix you a little bit. All right, so this time we have to do all of the math. So we do 824 times the 6, and we divide that by 17 times 4. And so you should get 72.7 roughly moles of H2O. So your book gets slightly different answers because they use different values. Remember, they don't round to the whole number. They go to 2 decimal places. If you plug this into your calculator and you did not get 72.7, most likely, if you tried to put this into your calculator all in one step, you have to remember to use parentheses. Okay, so if you do 824 times 6, put that in parentheses, divided by, open your parentheses again for 17 times 4. Okay, otherwise it does the whole thing and then divides by 4, and so you get the wrong answer. Okay, if you do, or it multiplies the whole thing by 4. If you don't do parentheses, and so then you get the wrong answer. Use parentheses, okay? Or do it a step at a time and kind of write down your numbers. Okay. So we'll do this one again together, and then you can pause the video and I'll do the last one on your own just to make sure that you have it down. Okay. So in question 2, we are producing chlorine gas by taking sodium chloride and passing an electric current through it. So we produce sodium hydroxide, chlorine, and hydrogen gas. So we start with 250 grams of chlorine, or of sodium chloride, and we're finding the moles of chlorine. So 250 grams of NaCl NaCl, the mass is okay. 23 and 35. That's my answer. 58. In 1 mole. And then this one is balanced for us. So we have 2 moles of NaCl. And we have 1 mole of chlorine. So I would do 250 divided by 58 times 2. Remember, if you're going to do that in one step, then you need to use parentheses. And nope. Sorry. Let's get this so that you can actually see what I'm typing into the calculator. I'm just making a mess. Okay. All right, well, there we go. Okay, so I'm going to do 250 divided by 58 times 2. So I use the parentheses on that bottom term at least. And so I get 2.16 moles of the chlorine. The second part B, says how many moles of hydrogen can be produced? So I would do the same thing again. If you're looking here and you're going, hey, that has the same coefficient for the hydrogen as it did for the chlorine, everything else is going to be the same too. It would in fact also wind up as 2.16 moles of, oops. Somebody is just having a struggle today. It's me, by the way, it's me. Okay, so I'm not going to redo that, all that math. I'm going to assume at this point you're kind of keeping up. Okay, if you're struggling, you're really still not quite sure, or you want that practice, go ahead and do that one. So now this is problem 3. It's the third and final problem that we're going to do for this type of equation or this type of series of steps. So you should pause the video, try it on your own, and I'm going to go ahead and work it. So this is a cancer treatment. And we get it through this crazy thing. I don't even know what this thing is called. Wouldn't even begin to know what to tell you. All right. So we are going to figure out how many moles of it, though, are going to react in order to produce 30 grams of the other thing. Wow. Okay. PTCl2. Oops. Page 3. That's super fun. Okay, so the molar mass of this, PT, by the way, is platinum. 195 times 35. All right, so I'm getting 299 grams. I'm not going to write that out again. This time I'm going to be lazy. I'll let you be lazy too. And 1 mole. So our mole ratio here for this thing, 1 mole to 1 mole of the K2PT. CL4. All right. So I would do 30 divided by 299. Let's hope I did that correctly. So you should get 0.1 moles of the K2 PTCl4. Oh. And how many moles of ammonia are needed to produce that 30 grams? Thankfully, we don't have to do the molar mass again. So we have 30 grams of the PT compound. So 299 grams in 1 mole. 1 mole. The coefficient for NH3 is 2. So you would do 60 over 299 this time. And you get 0.2 moles of NH3. Yay. All right. The final type of equations. So these we're going to start with a mass. And we're going to end with a mass. We're going to do 3 steps this time. So we start, so this is just giving us some information about tin-2 fluoride, which is the fluoride source for some toothpaste, just in case you're wondering how they got that fluoride in there. So we react tin with hydrofluoric acid, hydrogen fluoride, makes the tin-2 fluoride and hydrogen gas. So we're going to figure out how much tin-2 fluoride is produced if we use 30 grams of hydrogen fluoride. So I start with the first thing is always what I'm given in the problem. And then I'm going to go from grams of HF in 1 mole. Okay, and then I need to do a mole ratio of moles to HF and go to moles of, in this case, the tin-2 fluoride. And then we'll go from moles of tin-2 fluoride. 1 mole is how many grams? So HF, the mass of F is 19, H is 1, so that one is 20. That's in the wrong place. Struggle bus. Okay. HF has 2 moles, and the tin-2 fluoride has 1 mole. The mass of tin is 119 plus 2 times the 19 for fluoride, 157. All right, so to do my math, I would multiply 30 times 157 and divide that by 40, 20 times 2. Okay, so I'm gonna get a fairly large number. 30 times 157 divided by 40, 117.8 grams of tin-2 fluoride. Okay, hopefully I didn't go too fast, but we're just kind of adding on steps to what we've been doing. So let's keep going. Again, just don't get too far ahead of your own self. Slow it down if you need to. If you guys need to pause and go back and rewatch, do that. So practice problem 2, for going from mass to mass. We're reacting sodium peroxide with water and producing sodium hydroxide and oxygen. So we're going to figure out what mass of oxygen is produced if I react 50 grams of sodium peroxide. So I have 50 grams of Na2O2. Same steps. I'm going to go from grams of Na2O2 in 1 mole. That's the molar mass. And then I go from moles of Na2O2, which in this case is 1, to moles of O2. That's what I'm looking for. Again, 1. No, it's not, because I wasn't paying attention. It says unbalanced. Okay. So if we're going to balance this equation, I don't have an answer. So I'm going to start by doing that, putting a 2 in front of the water, so that I have an even number of oxygens on the left. I think I'm going to end up with a 4 in front of this. So I have 4 oxygens. If I start with, oh no, okay, I do that. Right, so we have 2 plus 2 is 4 oxygens, 2 and 2 is 4 oxygens, 4 hydrogens, 2 hydrogens. Two sodiums, 2 sodiums. Uh-oh. Somebody should have figured this out a little bit ahead of time. I'm going to pause and figure this out. Yep, come here. All right, I got it figured out. That one took me a second. Probably shouldn't have, but it did. All right, well, I just took a picture. That's great. Let me get back here to the screen mirroring. So you should have coefficients of 2 to 2 to 4 to 1. So 2, 2, 4, 1. So then my mole ratio, that one is a 2. Okay. And so then we do our last step, where 1 mole of oxygen is 32 grams of oxygen. So here we would multiply, oh, I still have to do the molar mass of Na2O2. So Na is 23. Plus the 32 for O2. 78, so 50 times 32. And divide by 156. So 50 times 32 over 156. Answer should be, yes, 10.3. Okay, good. Good, I did it right. Okay, it's always exciting. Now we're gonna figure out how many grams of water we would need to react with the 50 grams of Na2O2. So when it says react completely, that means what's the minimum amount of water I would need to totally use up my sodium peroxide. Okay, so again, I start with my 50 grams of Na2O2. The mass of that is 78 grams. In 1 mole, I have 2 moles to, let's see, 2 moles. And then I'm finding the mass of water. So, oops, that's wrong. That's my bad. I wrote the wrong thing. So 1 mole of water, 16, 17, 18 grams of water. So 50 times 2. My fingers are hitting the buttons faster than apparently my calculator can register. And we get 11.5 grams of water. So If I was going to use 50 grams of sodium peroxide, I would need at least 11.5 grams of water to totally react there. All right. And finally, again, this is where you should pause. Try this one on your own if you haven't been already. We're doing copper metal added to silver nitrate. It's going to produce silver metal and copper 2 nitrate. So we're going to have to write out our equation. Man. So copper metal, so we have Cu as a solid, right? We're adding that to silver nitrate, which is AgNO3. That one is aqueous, and that is going to produce silver metal and copper 2 nitrate. So this means that copper has a 2+ charge. If you look on the chart, the list of polyatomic ions, nitrate has a 1- charge. So CuNO3 2. And so I would need 2 of my nitrates to balance out the charge of copper. And then I would need to balance this, which this one is easier. So I have 2 nitrates on this side. I can put a 2 there for 2 nitrates. That gives me 2 silvers. Boom, done. Okay. So we're figuring out the mass of silver produced from 100 grams of copper. So 100 grams of copper. Copper has a molar mass of 64 grams in 1 mole. I have 1 mole of copper to 2 moles of silver. And silver has a mass of 107. So 1 mole of silver is 107 grams. Do math. I get 334 grams of silver. Your book gets 339. Oh, because this should be 108. That's my bad. So it probably is closer to 339. Yeah, I get 337.5. So 338. Okay. That's much closer. Okay. There we go. All right. So we do have some more practice. I'm going to leave a key for this. I'm not going to go through it with you right now, but I'll leave an answer key and you can do them and then check yourselves. Make sure you've got it before you go on to the homework. The homework should be pretty straightforward. So this, let's go look at the homework. It is front and back, but it's really just more of the same stuff that we've been doing. So one difference here that I'll point out with the airbag on, so this is question 6 on the back. So it's giving you liters. So in part A, it's going to have you use the density. Okay. So because we have liters here, we would set this up to multiply by the density, and that would give you the mass. Okay, remember the equation for that is actually so density, that's a D, is equal to, oh goodness, that's terrible. mass divided by volume. It's really hard to do this. And so if it gives you the density and what you need is the mass, right? You would do density times volume. Okay, so it gives you the volume, and then down here it tells you the density. So use this equation, find your mass, density times volume. And from there, you can go through the rest of the steps just like you had it. So. So that should be just fine. I don't think, 5b also has a density. So you'll calculate the mass and then use the density equation. Density is mass divided by volume to find the volume. So you have to rearrange that one. Okay. So that's a little bit of a challenge, but I think you can do it. All right. So again, let me know if you have any questions. Hopefully you don't. Hopefully, maybe just by watching this video again or watching one of the other videos that I put up on Classroom, you can manage to get through this.